Good morning, Doctor. Thank you for your classes as usual. So actually, one of the things that has been mentioned in this class is the process of pre-processing, process of filtering, not pre-processing, sorry. I think maybe this is the first time I was kind of maybe hearing of it. Maybe from the summer class, the filtering was not mentioned. So maybe I wanted to know how it's done. And secondly, I also wanted to ask like which platform was used for this study. Was it Weka or some other maybe platform like to do the actual result and everything to run the models? And as regards to the result presented, was it the result with the oversampling, like the result with where we were shown the confusion matrix? Was it the oversampling or without oversampling?
Okay, thank you very much. Yeah. Now, to quickly answer some of your questions. One, regarding when we talk of data filtering. What do we mean by data filtering? You know, when you get raw data, you see, for example, you got raw data. The data might be, if you are lucky, you have a data and everything is arranged for you. That is okay. So this data came in maybe kind of this database format. So huge data with a single patient having several visits, in each visit, several tests, unexpected information, repeated information. Then this is where we say, okay, we need to filter it and then to produce what we really need. You see? So of course, in order not to confuse you actually, you might have, this is a matter of maybe nomenclature. Somebody might call it data preparation. Data preparation. You get the point. Data preparation. You see, it involves a lot of things. Filtering can be there, cleaning can be there. You see, that is why you can see here, we just decide to put it as, okay, this is data collection stage. Because the data sent to us, the people who sent this to us, they were supposed to make it in an XDR that can be easily used, but maybe they don't have the capability or they don't have the time to give us the raw score that's really, if someone who doesn't have experience cannot make use of that data because it looks so useless. Yeah, because there are a lot of repetitions here and there. Then that's why we have to first of all figure out how can we bring this data to the form that we really need. This is why we just coined that particular word called it filtering. That is, we want to filter the junk data from the one that could be useful. And that was what led us to getting from 435 feature and 53,000 samples. Just imagine that size. We were able to bring it down to just 80 feature and 152 samples. So a lot of things have been removed, either because they were repeated or they were not supposed to be there, and also for that. So because of the activity was so huge that imagine we have to even use parallel system to make it easy to filter the data. That's why it was considered that, okay, it should be separated from the normal data pre-processing, because it's an activity that ordinarily people don't need it if your data is presented to you in a normal way. So you don't care about that. For this case, we didn't have that particular privilege, so we had to do that on our own separately. So, and it's not compulsory you must do this in your work. You see, if your data comes up to you in Excel file, in a text file, ready to go, that's okay. So you don't need all this kind of filtering and the like we just described. This is optional. Now, I hope that clarified that. So once we're done with that, then we now go into the data cleaning exercise, which involve all these outlier remover, missing value, normalization, which I think we have discussed this during the summer school. I believe we discussed that. Yeah.
Yes, Doctor, we have discussed it.
Okay. So I think the second question is regarding the result. Is it over sample method or under sample method? Am I right? Yeah.
Yes, when we are showing the result under confusion matrix, the numbers seems like.
Yeah, it has to be over sample actually. Yeah, this has to be over sample, because in over sample, you try to make it to become as close together as possible as, you want to make it as close to each other as possible so that this is going to be, this is total, here is total of 89, here also is 89, yeah. You see, we try to increase the smaller sample to meet up with the higher sample. You can see they become the same size. So this is the result of oversample method. You can easily figure it out easily, actually, because the data we had then has only 53 samples. So there's no way we could have it. It's 7 here. Yeah, it was oversampling, result oversampling that is reported here, the smooth method. And like I said, we're going to discuss it in detail when we look into the actual paper. I hope I asked all your questions, Madam. Is that all?
Yes, yes. Okay. The only one left is about the week. Is it weaker or something?
Okay, thank you very much.
This,
the student, they will start actually some of our, like the previous one we presented, like thyroid cancer was made in weaker environment. But for this one, especially when they encountered the issue of this parallelization, we have to write some codes in Python to be able to filter the data. So the experiment was actually carried out in Python environment for this one. Yeah, it is in Python environment. But aside from this, every other thing also could be done in any other platform. Now.
Okay, thank you very much, Doctor.
Okay. So the next person is Mr. Isaiah.
Okay, thank you, sir.
Okay, you're welcome.
It's done. Yeah, thank you very much, sir. Sincerely speaking, I must thank you very much for these classes. For quite some time, I've been using Worker, but this is in a very broader view. There are so many things that you mentioned that have not, for once, made use of. Now, my question is a bit similar, but different.
Okay.
Now, when you have, assuming that I have a kind of data set whereby I have actually extracted significant attributes, and I wish to determine the weight of each of these attributes, is there a way one can achieve this using Worker?
Yeah.
And two, okay, I think you have answered my second question from the last student. Let me use the word participants.
Okay. Okay, thank you very much for that. Yeah, I want to believe that was a similar question maybe a few weeks ago we came across. Yeah, actually, there are different types of feature selection. Yeah, I am not sure if you have had the opportunity of checking through our video on feature selection. So there are different types of feature selection, and then maybe you will also have the opportunity of discussing feature selection again. So where we are going to also shed more light on it. See, yeah, maybe last week also, yeah, I think I mentioned it. You see, we have univariate feature selection, univariate. Univariate means you want to consider each of the features as a whole, individually. This is what you are talking about. So you want to be able to see what is the weight of this feature on the data I'm having with me. How does it contribute to the predictive solution? So this is under what we call univariate feature selection. Univariate feature selection. So you treat each of the, let's say I have X1, X2, X3, then you have Y, the target. You look at how is this X1 going to affect my Y, which is going to be predicted? How is X2 going to affect it? So we try to do what we call, this is under the type of feature selection. Apart from being univariate, we try to generate a value for it. And one of it is what we'll be mentioning. What is the correlation coefficient? Correlation coefficient is very simple. We can do it in Excel. We can do it in Weka, by the way. So you go to your Weka here. You can have, yeah, you have Weka here. I believe you guys can see my Weka here. So you can see here, this is selecting attributes, you know, this is selecting attribute. I already input this, our friend data, our data to predict diabetes without medical stuff, just by questionnaire. So you go to select attributes here. You see, you have different, okay, this is based, you have different methods you can select from. You can see here. You see, this is classify attributes, evaluation, classify subset, evaluation, correlation attribute, evaluation, gain ratio attribute. So you can use gain ratio, you can use information gain, one attribute, evaluate, principal component analysis. There are a couple of options. But the one that is very simple, you can easily relate to, closer to what you mentioned, is what they call here, either you use gain ratio or you use correlation coefficient. This is simple. Everybody knows this. Even in Excel, you can do it. So if you click this correlation attribute evaluation, you see, so once you just start, what it has done here is it has assigned your attribute some ranking values. See, the attribute we saw here, each of these attributes have been evaluated here. You go here to do that, select attributes. See, inside there, you have many options. I've only selected correlation attribute. You can use gain ratio because this works for individual. You see, there are others that work for subset, like classifier subset evaluation. That one will take group of features at the same time. Now, so this simple one, what has done now, you can see here is saying that polyuria is having 0.66. This is the kind of value you're asking for, actually. It's saying this one is having 0.66. See, polydipsia is having 0.64. Then you can see it goes down. It's telling you the number of these attributes in the list. According to the list we have here, that's the number 1, 2, 3. That's the one there. But the one you are asking for is these values. You see, it has a sense of weight. This is the weight of this, feature, the weight of this, the weight of this. You can see it arranged them according to as they go down in descending order. So the extent the itching has very low value. So if you want to run it now, you can decide to say, okay, the one I taught you before, I call it recursive feature elimination. You select the best. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You select the best from this 15. No, these are 16, yeah. You select the best, divide it by 2, you have 8. Select the best 8 from top. 1, 2, 3, 4, 5, 6, 7, 8. So you stop here, run the experiment using all these first 8, divide 8 by 2, you have 4. Then select the best 4 again, run your experiment again, divide it by 2 again, remaining 2, until it becomes 1. This is what we call recursive feature elimination, and see what you can get. Sometime with that, because you are going to run it for one feature, the best feature, 2, 4, 8. The others, you ignore them. This is called recursive feature elimination based on correlation coefficient values. You can also use other values like gain ratio, like I mentioned earlier. However, this is univariate feature selection. You have just assumed that if I select the one that has these highest values, they can give me better result. But sometimes it doesn't work that way. If your data cooperate, that's why I always say, don't forget, let the data speak. Some data said by just doing this simple one, it works fine. So you get the best result. You can even get 100% by maybe when you use the best 2 or the best 3, as the case may be. However, sometimes, even though this itching has very low value, if you combine itching with this polyuria, you might be surprised that you get better results sometimes. This is why the idea of multivariate feature selection comes in. And that is what we did in the reported work now. You see, we try to combine different combinations. 1 and 2, 1 and 3, 3 and 4, 4 and 5. We allow the algorithm to look for the best that can work with it. You see? So this is what we did in that case. But however, I do recommend this simple one, this correlation based. Just calculate the value, the weight you are looking for, and select those with better weight. Usually it makes sense. The one with better weight, if you combine them together, it will give you better results. And we have done it, by the way, we've used it successfully in several work. But sometimes it doesn't just work for us. Then we have to go to other complicated methods like this multivariate. try to combine 2, 3, 4, 5. Look at the combination of different ones. Because sometimes if two features, it's like you have a brother, hey, somebody has like maybe 3 brothers, you have A, B, C. If these 2 people are paired together to work for you, they work very well. The 3 of them, they are excellent students. But if these 2 are paired together, they work for you. But if you pair these B and C, they're going to be discussing too much. They will not achieve the work they want to do. Then we said that if I'm going to pair them, I always pair these 2 of them, and I pair this C with A. I will never allow B and C to go together. This is what we call the multivariate features. So sometimes combining multiple features might be what we need. But like I always say in machine learning, you start from the simple to the complicated. So don't jump to just the multivariate. Try to use the simple one, which is the correlation. Find the weight of each feature. Based on the weight, decide to select those that can work for you. I want to believe, I hope the question is well answered and is clear. Yeah. Okay, thank you. So third one, this may be second to last question is, I can see, this is Sefinat Muhammad.
Okay, assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum salam wa rahmatullahi wa barakatuh.
My question is it possible for us to have a multi-stage classification? What I mean by that is checking on the severity of the positive cases, like very severe, not mildly severe, something like that. How can we go about it? And that's my first question. The second one, about this feature selection, I just want to know the method you have used. What category of feature selection methods does it really fall into? Is it the filter method or the wrapper or the hybrid? And thirdly, since you've done a lot on pre-processing of this particular data set, I don't know if there's any, if it can be made publicly available so that you can try out that classification algorithm on them. Thank you.
Okay. Yeah, thank you very much for your questions. Starting from the first question. So I think that's related to, can you just remind me quickly, sorry? The first question.
On the, sorry, multi-stage classification.
Okay, yeah. Multi-stage classification. Yeah, it's a very nice idea. It depends on the availability of the data set. You see, if the data set has, I know some diseases are really severe, So like we discussed, one of these we discussed before was what do we call it? COVID-19 fear. What do we call it then? Yeah, that was a case of COVID-19. We wanted to determine if somebody is having a kind of anxiety, COVID-19 anxiety prediction. So in that case, we have one of the experiment, it was 2 cases. Either you have anxiety or you don't have anxiety. That was a 2-class problem. The second stage was, if it has severe, mild, and none. There's none. Yeah. So it depends on the data that is available for all. So in that particular data, they did in such a way that they collected data for anxiety and non-anxiety. They move further again and also label the same data for severe, non-severe, and none. So in that case, it depends on the data that is actually available. But however, the more the number of classes, the more challenging getting higher result becomes actually. So binary classification is often easier. And that's why sometimes when we have multi-class problems, like it has class 1, it has severe, medium severe, normal, and then none. There are 4. Sometimes we try to bring them to 2. We can partition them into 2. You see, first of all, class 5 severe, assume everything is non-severe, and this is severe. So you first of all remove severe, then you move down, medium, assume everything is medium, and the next one is nothing, You remove them. This is depend. Sometimes when we want to solve problem, when the number of class label is much, we try to break them to binary. Then that is going to be multi-stage. We first of all remove severe, we go to medium, then we go to none, as the case may be. But then it is possible, but subject to the availability in the data. But the data we use doesn't have this. It does have Alzheimer is present, Alzheimer is not present, because they are patients who have been treated or attended to in that clinic. They identify them. These ones were never treated for this disease. And then both of them, they sat for the same medical test. They did the same blood work. So in that case, it works. But if the doctors actually label it accordingly, that these are the patients we visited, this one has severe Alzheimer, this one is mild Alzheimer. It would be nice to have such data. That's going to be a totally different work in that direction. Thank you. I hope that's answered that question. And the second question has to do with, pardon me, the...
which category of feature selection?
Yeah, thank you very much. Yeah. So this is actually, it's a every day things keep coming up, new things are being added, are being explored. This is something unique about machine learning. See, usually we have, univariate, where you consider only one feature at a time. What is this feature contributing to this business? And then we have multivariate. So that is multivariate or univariate. But when do we use it? Do we use it before it enters the machine learning? This is where filtering comes in. We have filtering method. Does it enter before? So the correlation coefficient, the example I explained in the response to Mr. Isaiah's question, is an example of filtering. We filter the feature based on a particular weight that we assign to them. What is the contribution this feature is having in respect of the predicted output to be predicted? So we filter based on that. We remove some before we even run the experiment. This is called filtering. Then in the wrapper method, we let the data enter, the complete data will enter the modeling stage. So we now use the model to search which feature is going to work for you. Try to check, it's up to you. So this one can fall under the wrapper method. So we use the wrapper method because we allow all the features to enter each of the model, and we allow the model to pick which of these features work for you. Which of these features will make you as a model to be able to get the best result for the target we are looking at. So this one identifies 6, this one identifies, even this that identifies 6, you can even see that the 6 is different. This one is having hematocrit, this one is not having it. So even the one that identifies 6, there are different combinations. So this is an example of wrapper. So the other one described for Mr. Isaiah is an example of filtering. And sometimes we do the mixed mode, the hybrid, whereby you do both filtering and wrapper and combine everything together. Like if I want to do wrapper, after getting if I want to do the wrapper, after getting the weight, I then try to combine them at different level, try to see which one is going to work for them. In that case, you are going to an hybrid level. And thank you for that. So categorization. So we use wrapper in this case because we allow it to enter the model and then let the model select what is good for it. So that could be categorized as the wrapper method. And the name is sequential forward feature selection. There's also backward. This is sequential forward. There's backward feature selection, whereby you start from one and keep adding, that is forward. In another backward, you start from complete feature and you keep removing them. And then we have the hybrid, whereby you add, you remove, you add, you remove. All these things are possible. Yeah, in feature selection. And finally, the question that says, yeah, this data, luckily this paper is going to be published, is going to be posted on our platform because it's a free access paper. It's published in open access. Everybody can have access to the paper as the case may be. So we're going to post it, and we are free to share with anyone we want. However, for the data, because there is what we call there's a kind of a permission that needs to be gotten before the data could be released, because this is live data and just be released less than maybe a couple of months. So we seek their understanding before we actually can share it with people actually. So because we have to sign some documents and there are some conditions, be medical data and the likes. But personally, I'm always very interested in this. We pursue that at an appropriate time. Whoever is interested, please kindly, you can contact me. We'll try to see how we can make the data available, even if it's going to be anonymous, as the case may be. So I hope we have answered the question. So thank you. Yeah, thank you very much. I think Mr. Chris has shared our YouTube videos on feature selection, so we can also check it out to get better stuff there. So I think this is how we are going to have it for the day. Like I said, if you have anything you need of data set or other stuff, feel free to engage me appropriately, and we try to see how we can be of help to ourselves. So wish you all the best. So thank you very much all. This is how we're going to have it for the day. Thank you for coming.